All right, we're ready to go here. With the target gas law lamp, what you're going to want to do first is you're going to want to fill up this graduated cylinder, overflowing. You want as much water in there as possible. You're going to take a piece of, let's see, what's the cling wrap? Plastic wrap. I can't use saran wrap, it's trademarked. Just use it. All right, what you want to do is not what I just did there. You don't want to get any air bubbles. So you want to have a spare beaker. You don't have to use a giant one like I am. And you want to just you want to finesse this over the top. And that's good. You know, you're going to get 1 or 2 air bubbles. Small ones are better. You're going to hold the whole thing as best you can. You're going to wind up flipping it upside down. So I suggest you actually put your hand upside down as you try to attempt to flip it. That way it's right side up. Get it into the water and set it down on the bottom. Okay. Once it's in the water, you just want to keep the base of the graduated cylinder under the water, and you'll just pull your saran wrap, your cling wrap, out. Set that aside so it can be reused later. You're going to maneuver this over and stick it in the clamp and clamp things down. Ultimately, when you get this moved into place, your water trough has a hole in it. You want that sitting right over the hole. The ultimate goal is not to have any air bubbles in here if you can. So take a minute or two to try and do that. Okay. You're going to also obtain a piece of zinc from me. You want to be sure to mass this using a 100th place balance. And then the next thing you're going to do is you're going to sit around and do some math for a while and figure out exactly how much hydrogen gas this will produce when it's placed in your hydrochloric acid. Once you've got that done, you're going to obtain about 50 to 60 milliliters of 6 molar hydrochloric acid. Now this is not marked and graduated, so that's going to make obtaining 50 to 60 a little difficult. I'm going to estimate. That's about 60 milliliters right there. Notice it's 1 finger of acid. So what you need to do is you need to actually get a way to put the zinc in there. The best way to do this is to actually fold your zinc in half. You don't want to just drop your zinc in, because if you drop it in, it's going to start producing hydrogen gas and you're going to lose it before you get a chance to put a stopper on. So what we're going to do is we're going to fold this twice. We're going to fold it once, put the paper clip on it. Now the paper clip is coated in plastic, so it's not going to react at all in the reaction. And this is the tricky part. We have rare earth magnets which are extremely strong. What you want to do is you actually want to get your finger into the flask and get the magnet to hold onto the paper clip. It'll do that through the glass just fine, but you do need to get your finger in there, so make sure there's no acid around the neck. Once that's done, you're going to go ahead and put the stopper on. Anyway, get an idea of the whole thing here. Alright, so this is the nice little piece of plastic. It is going to tell you your grade. Obviously a 10 is full credit and 8 is 8 out of 10, which is a B. So you have to guess, you have to measure exactly where it's supposed to fall. Now remember, you're measuring the graduated cylinder upside down, so if you're predicting 100 milliliters of gas, you're going to make a prediction right here. 200 milliliters right there, 210, 220, 230, 240, 250. Okay, so you're going to have to actually think upside down as you do this. But let's say that I was estimating it to be, let's say, 420 milliliters. If I was expecting 420 milliliters, I'm going to tape my 10 out of 10 right there at 420. And then the last thing to do we see that? It doesn't want to.
It's a little tough on the focus.
Okay, maybe we can take a picture of it. But you'll put your 10 out of 10 exactly on 420. And then the last thing to do here is this. You're going to just release the magnet, which I will do the other way around. Release the magnet, and you will see a definite chemical reaction begin. It will bubble, it will sizzle, and the gas bubbles will be collected by water displacement. It actually sounds like somebody's taking a drink.
That's why you want the hole
Mm-hmm.
underneath that.
Wow, it's going a lot faster all of a sudden. I wonder if it just broke into pieces.
It's possible.
Probably.
Stirring it should help.
Yeah. Agitation. Okay, it can stop any moment now. Stop. 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 Good thing I didn't do the math. I passed up an A. I've just passed up a B and a D, and I'm passing up an F.
Closing in on epic fail.
Oh, get this over here. The water trough does have a siphon off the side, so that the water will wind up going into the sink. Please make sure that the water's going into the sink at some point. Once all the bubbling has stopped, we're going to take a look at it. We're going to give you a grade.
Well, it only looks like you're off by 200 milliliters.
Which is 2/3 of what I had guessed. So maybe I get a 66%.
33% error is not bad for a chemistry lab, is it?
And then I'm going to show you something a little bit fun to do, which I'm going to turn off the lights for this. So the neat way to finish off the reaction is this. We know that this is hydrogen gas. We have to prove it. So we're going to move it over here, flip it upside down, and we know that the test for hydrogen gas